does a bank decide whether to give a loan to a small business? Let's say you run a small tea shop, a garment unit, or a kirana store. You go to the bank and say, I need 5 lakh loan to grow my business. The bank asks, what is your CIBIL score? And you say, I don't have one. And the bank says, sorry, we can't help you. This is the reality for 6 crore 30 lakh small business in India called MSMEs. They contribute 30% of India's GDP. They employ 11 crore people, but they can't get loan because they don't have formal credit history. So today we are going to show you a project on KNIME we built that answer one big question. Can we predict which small business is going to face financial trouble without using a CIBIL score? The answer is yes. Let's break it down all together. Hello everyone, I am Rani and my team is going to break it down. The data set containing 15,106 record and 33 variable, and the best accuracy is 93.83%. ROC minus AUC score is 0.9931. Let me explain the problem in a very simple way. Imagine you are a bank, someone walks in, a small business owner, a tailor, a carpenter, a food stall owner, they want a loan. You normally check their CIBIL score, that a number that tells you has this person paid back loan before. But most small business owners have never taken bank loan before. So their CIBIL score is 0 or blank. Traditional banks don't know what to do. So they say no. This creates a credit gap. A gap between the money small businesses need and what they actually get. This gap in India is estimated at over 20 lakh crore. That massive number. Now here is the key question we asked. Even without CIBIL history, can we find other clue that tells us whether this business is likely to fail financially? For example, does the owner know basic accounting? Do they plan their cash flow properly? Do they take risks financial decision? How old is the business? How stable their cash balance? We said yes, these things matter and we can use them to build a model that predict financial distress. That's exactly what we did in this project. Now, let me explain the data we used in our project. The contained data from 15,106 small businesses. The most important column is the data set was called financial distress. It had only two values, 0 and 1. 0 means the business is financially healthy and 1 means the business is in financial distress. Out of 15,106 businesses, around 10,000 businesses were healthy and 5,000 businesses were is distress. This distress and 33 different features about each businesses. These features help us understand the financial condition of the businesses. Some example are: first, business profile, age and sector of this business. Second, financial literacy, whether the owner understands accounting and credit. Third, risk behavior, whether they take risky financial decisions. Fourth, decision making, how they manage loans and cash flow. Fifth is financial stability, cash balance and revenue condition. One good thing about the dataset was that it had 0 missing values. So the data was clean and complete. After collecting and understanding the data, we trained a machine learning model to predict whether a new business may face financial distress or not. That's the data part of our project.
Now let's talk about how we built this model. We used a tool called KNIME Analytics platform. Think of it like a visual flowchart tool for data science. You don't need to write code. You just need to connect boxes and each box does a specific job. Our entire process was broken down into 6 steps, one after the other, and that are: here we run the CSV file. Pre-processing through multiple nodes like the number to string, column filter, normalizer, and more. Exploratory analysis. Here we saw the comparison between visualization. Class balancing. We use mod on training data. Model building. Strategically split data into logistic regression, decision tree, and random forest and H2O AutoML. Evaluating an output. We evaluate the conclusion through scorer nodes and H2O benchmarking. Starting from loading the raw data all the way to testing and comparing the two models we build, each step is separate and repeatable. So if something changes, we can easily fix just one part. And since both our models were trained in the same environment, the comparison between them is completely fair. Before we could train any model, we had to clean and prepare the data. This happened in 3 steps. Pre-processing. Before building the model, we cleaned the data, removed unnecessary variables, and scaled all the features to the same range. This ensured that the logistic regression treated each variable fairly instead of being influenced by larger numerical values. Exploratory analysis. We then explored the data using pie charts, bar charts, and histograms to understand its patterns. Early visual analysis revealed that some SME categories appeared more frequently in the financial distress group. While not a final conclusion, this insight helped guide the next stage of our analysis and model development. Smart, our dataset had healthy SMEs than distressed ones, about 66% versus 34%. That's a problem because the model might just learn to always say healthy. So we used a technique called SMART to artificially create more distressed SME examples in the training data so the model learns both sides properly.
The exciting part is building the actual models. We built 4 models. From that, we selecting 2 models and compared between them. First model is logistic regression. This is a classic simple model. It looks at all the input variable and gives a probability like this SME has 70% chance of being in distress. It's very easy to explain, which is important in banking and finance because regulators wants to know why a loan was rejected. Our second model, random forest. This one is more complex. It builds hundreds of decision trees and takes a vote. It can pick up complicated patterns that logistic regression might miss, but it's harder to explain. Both models were trained on 70% of the data and tested on the remaining 30% under the exact same conditions, so the comparison is fair. Let's look at how well our models actually perform. The main result here are for logistic regression. Out of all the SMEs in the test set, it correctly identified 2,761 healthy SMEs and 1,488 distressed ones. It only made mistakes on a small number of cases. The overall accuracy was 93.83%, means it got nearly 94 out of every 100 predictions right. Even more impressive in the ROC-AUC score of 0.9931. This is basically a measure of how well the model separates healthy SMEs from distressed ones. A score of 1.0 would be perfect, so 0.9931 is extremely close to perfect. Random forest, it didn't do as well. It fell short on every single metric. This slide shows the confusion matrix in more detail. Basically a table that tells us where the model was right and where it went wrong. We can see that the errors are very few and the model is particularly good at catching distressed SMEs before they become a problem for the lenders.
Now, here we compare the performance of our 2 models, logistic regression and random forest. Logistic regression emerged as the clear winner, outperforming random forest across all evaluation metrics. It achieved an accuracy of 93.83% and an ROC-AUC score of 0.9931, demonstrating excellent predictive capability. It shows that alternate data can effectively assess us MSME credit risk. Let's see what the model tells us about MSME risk. Our analysis revealed 3 key insights. First, financial literacy is a strong predictor of financial health, with financially aware businesses showing lower distress rates. Second, decision-making quality matters, as MSMEs with structured financial decisions were generally more stable. Finally, liquidity and cash flow management proved to be more reliable indicators of financial health than revenue alone. Now, based on the predicted distress probability, lenders can adopt a simple 3-tier loan decision framework. Low-risk MSMEs can be approved quickly, medium-risk MSMEs may require additional review, and high-risk MSMEs can be flagged for rejection or further assessment.
Based on these findings, we recommend improving financial literacy, incorporating behavioral factors into credit assessments, and focusing more on liquidity and cash flow stability when evaluating borrowers. These measures can help lenders make more accurate and inclusive credit decisions for MSMEs.
A study shows how alternative credit assessment can help to bridge the credit gap for millions of MSMEs. Thank you.
Thank you EIM Kolkata and Dr. Professor Kaushik Datta and our mentor Sharmishta Das for giving us this wonderful opportunity.